In this video, we're going to take a look at the TAL distributors database, and we're asked to calculate a discounted price of 10% off the normal price. And we're going to give that a currency format, and we're going to also rename the calculated field. So let's see how we do that. As always, let's start with selecting everything, and this is going to work on the items table. Okay, so there's our item table. So it looks like we're on the right table, and the price is what we're interested in. And so we're going to work on that field. Also, we look at the requirements. We want the item number and the description, and then we're going to be playing with price. So let's get just those three fields here to begin with. So we want the item number, the description, and the price. And check that query. Okay, so we've got it narrowed down a little bit. Now, the price here, we need to manipulate. We want that to be a 10% sale. And depending on how your math brain works, there's a couple good ways to calculate that. One is we could say 100% of the price minus 10% of the price is what we're looking at. Give that a try. And this is, note that this is about $23, and 10% would be $2.30 less than that. Let's see if we come close. Yeah, okay, so sanity check, that looks like that's working. Now, this may be a big ugly thing. Some people's math brains may say, you know, when I see 10% off, what I really know is I'm paying 90% of the price. So if you would rather simply do it this way, 0.9 times the price is 10% off, that's fine. That's exactly the same thing. And let's double check that. We run it. Nothing changes. We still see it's 10% less than it was. That's good. But this is ugly. This is not currency in the US dollars and cents format. So let's use the format function. Format this big ugly thing. And how would we like to format it? The C character says currency. And currency could be won, baht, rubles, pesos, a lot of different currencies. We need to tell it what kind of currency, and we're working with English US units. So that'll be dollars and cents. And let's run that and see if that works. Nice. So I got the dollar sign, and I got the decimal place and a decimal point and 2 decimal places to the right for cents. And so that's the US convention. That's working nicely, but I still have no column name, or in some databases I might have this whole ugly expression up here, and that really isn't what I would like to have. We wanted to call that something. They said call it discounted price. Okay, so let's call it discounted price. And you could just follow this up with the word discounted price, and it will alias it. But I like to use the explicit as keyword. I think that's clearer. And so it should work just the same either way, but let's run that and see. And now it is the discounted price, and we're 10% off. And let's double check our results and make sure that we have met exactly all of the requirements. So TAL Distributors is considering discounting the price of all items by 10%. Yep, the calculation here is 10%. List the item number, we did. The description, we did. The discounted price, and name the discounted price discounted underscore price, we did. And so we've met all of the requirements. Nothing further is required. Pay me the points, Professor Beck. That's it for this video. This parallel problem poses the question, how many trips originate in each state? Let's start with the trip table. Okay, so here we have the entire trip table, and we certainly could count the number of trips there are, and it does tell us what state they originate in. So we can get easily a count of everything. There are 41. You could also say count just the trip ID. Again, same answer. But what we need to do is we need to break this down by the individual states. So we're going to need to group those states together. And here are my individual states all grouped together, but I need to get the count incorporated back into that. I can reintroduce trip ID, but that's not an aggregate function. I need to, at the same time, make it a count. And now I have the count by state. And let's, as a nicety, order those by the state alphabetically. There we go. So we see we have 2 in Connecticut, 4 in Massachusetts, 12 in Maine, 19 in New Hampshire, and 4 in Vermont. Have we answered our question? How many trips originate in each state? Yep, I think we have. This exercise asks us to do the following in Colonial Adventure Tours. Colonial Adventure Tours calculates the total price of a trip by first adding the trip price plus other fees and multiplying the result by the number of persons included in the reservation. Once we have that, it says list the reservation ID, trip ID, customer number, and total price for all reservations where the number of persons is greater than 4. Use the column name total price for the calculated field. First thing we need to do, as always, is figure out what table we are working on. And this should be, unless I miss my guess, in the reservation table. Okay, so here's our reservations, and there's our other fees, our trip price, the number of people, everything we need to do that calculation. So let's start working on it. It says, again, add the trip price plus other fees and take that sum and multiply it by the number of persons in the reservation. Let's see if that works. Okay, so we've got that calculated. List the reservation ID. So let's put that back in. The trip ID. and the customer number. And this is the total price. And the column name for this is going to be total price. So let's take this and say as total price. Notice at this point, we haven't accounted for reservations where the number of persons is greater than 4. Let's just see if we can get this calculation working thus far. Okay, so I have the reservation ID, the trip ID, the customer number, and the total price. But we need to filter this, and we can check this, sanity check it temporarily by momentarily adding back in the number of persons in here. Okay, so num persons. And this is just here for us to double check. So here they all are. And we want to filter this so only those trips that involve more than 4 people or 4 people or more persons is greater than 4. So not 4 people or more, it must be more than 4. Let's add the filter. Where num persons greater than 4. Sanity check, yep, num persons is greater than 4. But remember, this is not supposed to be shown. That's just part of our logic. So let's go ahead and remove that. But we'll leave the filter there so it'll still work. And there we are. Have we met the requirements? Let's see. List the reservation ID. There it is. The trip ID. Yep. The customer number. Yes. And the total price, which we calculated, for all reservations where the number of persons is greater than 4, use the column name total price for the calculated field. Didn't request any other ordering or sorting, no other filtering other than greater than 4, so we're done. In this parallel exercise, we're asked to find the number and name of each customer whose name begins with the letter C. This will require the use of the keyword like and some wildcard operators. Let's start as always with select star. And here are all of our customers on the tile table. We want to filter these down so that we only have the number and the name. And then further, we need to filter this so that we only get those whose customer name begins with the letter C. Okay, so let's think about this in terms of wildcard. So we want to find all of the customer numbers and customer names from customer where customer name is like something. How do we say that expression? We want it to start with the letter C. So it's going to have a C followed by anything. So we replace that with the wildcard for any number of characters, the % sign. Make that a single quote. All right, give it a try. Nice. So here we have limited to only customers whose names start with the letter C. Now, if the problem had asked, we could elaborate. So let's say that we wanted to take this to the next step. What if we only wanted customers that started with the letter C and also ended with the letter E? So we know there's an E in there, but the E could be at the end. So this says any characters coming before and ending in E. So we've said starting with C and ending in E. And it's important that we get that and right. Let's check this and see if it's working correctly for us. Okay, so Cards and More starts with C, ends with E. Crest Store starts with C, ends with E. If we had been careless in our Boolean logic and said or, we would have gotten the wrong results. There are many that either start with C or end with E, and some of them happen to do both, but we want to restrict this to only those that do the first and the second, that start with C and end in E. Here they are. And we could elaborate this even further. Let's say that we also wanted to find those that have AND in the middle. We could do that this way. And customer name, like, any characters, and then AND followed by any characters. So notice, a character followed by a wildcard says starting with this character and then followed by anything. A wildcard, a set of characters, and another wildcard says containing that exact expression anywhere in it, either at the beginning, at the end, or anywhere in the middle. And this last one says starting with any group of characters and ending only in E. And check this. Crest Store does not have an A and D in it, so when we run this, that should disappear. Nice. Cards and More starts with C, has A and D somewhere in the middle, and ends in E. That answers the question.